Well, hello Internet, and what we are going to do now is get the FPGA development environment in place. So if you haven't already watched my video which describes the FPGA development flow, do see that first. And now this is the continuation of that wherein we would get the necessary tools in place. So yeah, to start with, what we'll do is go to Google and ask it about project icestrom. And the first link which we get, which is www.clifford.at/icestrom, is what we want. So once on this website, this website is maintained by Mr. Clifford Wolf, who is the one who basically made the project icestrom and maintains it. And once on this website, what we want to do is go down to the section which says where are the tools and how to install. So now in my case, I'm running a Ubuntu machine. So what I'm going to do is copy this, whoop, okay, and paste it here. Now I have already installed these tools. So in my case, it wouldn't, and so it would just say that there is no new package to be installed. Okay. Now once you're done with this installation, we would need three pieces of software as part of the icestrom project. So number one would be the icestrom tools. So what these tools are is a set of utilities like icepack, icebox, iceprog, etc. And we would need this to, let's say, flash our binary file onto the FPGA. So these are needed for that. And we would need a place and route tool, which is basically your arachne-pnr, which converts the net list into um, a kind of it basically takes the net list and then converts it into the mapping onto the FPGA, like how it has to be on the FPGA, which bit needs to be set, not set, and things like that. Um, and then you would need the Verilog synthesis tool, which in this case is Yosys. So what Verilog synthesis tool does is it takes the v file, .v file, and then converts it into a netlist. Now to install this, what we'll have to do is we will have to just make a folder. I've already made this folder, so I wouldn't execute this command, but you would have to. So now let me just get into the icestrom project directory. Now once here, what we're going to do is execute this three git commands, git clone commands. And what this git clone commands do is they fetch the repository which is at this location into a folder by this name, and it would create the folder for you. So now I have executed these three git commands already because it takes a while for them to download the repository. So I've already done that. You can see that we've got the Yosys directory, icestrom, and arachne-pnr. So then following this, what you would have to do is get into each directory and execute these three commands as is. No change in that. And this also takes a while, so I have done it already. And what this would do is basically compile the source. This make command would compile the source for you, and sudo make install would install it. So after that, if I were to write Yosys, my system would know what those commands are. Okay, so I've got these three things already installed by following this uh, set of instructions here. Now, once this is done, what we want to do is we want to be able to access our FPGA without the administrative privilege. And to do that, we'll have to create a file at this location with this name. Okay, and the way you do that is you can just say uh, gedit and just paste this. And once you open it up, yeah. So okay, just a second. So once you open it up, you see this line here, which is listed here. So you basically take this line, this one line, and paste it in this file, and then save the file, which I have already done again. So once done, we're all good to go. And now what we are going to do is we are going to execute sort of a hello world equivalent of the FPGA program, or a Verilog which is hello world equivalent. And that comes with inside your arachne-pnr directory, so you can just get into that. And once in that, you can head into the examples. Once in examples, you only have one directory, which is the rot, which stands for rotation. So you just enter into that. And what you would see here is uh, a PCF file and a rot.v file and a makefile. So let's just take a look at the content of the makefile. And this makefile is basically um, um, an automation. So make is an automation utility, and makefile is what describes how that automation needs to go. Now, let's come back to the web page here, and if we scroll up, then what you can do is um, you can basically see here that there is an example of there is some Verilog file here, and it is converted into the blib file. This is discussed in the previous video. It is converted into the blib file, and then you take the blib file and the pin constraint file, and out comes a ASIC file basically, which is your final binary, except all the content is in um, contents are ASCII characters. And then you take the iSpac utility and convert this ASCII sort of a final binary file into the real bin file. And this bin file is what you would program to the FPGA. And you can see that iSpac and iceprogram are used, which are the utilities that comes with the icestrom tool installation. Right. So now if we take a look at the content of the make file, what we'll see is that it's basically doing the same thing which is listed here, right? So all we have to do is just hit make, and it would do all the magic for us. It would basically execute all of these steps for us. Now this takes a while, but it should be done. Yeah, it is done. And now if I do an ls, we can see that there is a rot.bin file generated, which is the final output. Now, before I put it onto the FPGA, I would want to show you the content of the .v and .pcf file. So let's just hit make clean to reset back all the generated files. And now you can see we only have the PCF and the rot and the make file. The rot underscore 8k is not useful for us right now. It is not considered. So let's just take a look at what rot.pcf and rot.v is. So rot.v. Uh, so now what this is basically starting from here down to this. This is basically describing a hardware that blinks different LED in different sequences. So this is written in Verilog. Verilog has its own syntax, and this is done. So this is basically the Verilog syntax that is describing the hardware. And now let's take a look at the PCF file, rot.pcf. Now here you can see that what it is doing is it is taking the variable d1. So let me also maybe just reduce the font size. Okay, let me do this, and let's also take a look at the rot.v file simultaneously. So now you can see that this command like set IO instruction is taking d1 variable, which you can see here, right? And what it is doing is it is assigning it to the pin 99 of the real hardware. Okay. So, and similarly, the D2, D3, D4, and D5 are being set to 98, 97, 96, and 95 pins respectively. And then there is this final thing called the clock. So turns out that this FPGA internally has a clock. Usually all the FPGAs have it, and so that the variable clock, the clock is attached to the 21st pin of the FPGA. So it's basically saying that take my variable clock, which is used here, and then attach it to 21. What you can also see is that this piece of syntax here, what it's saying is my clock variable is the input, D1 is the output, D2 is the output, D3 is the output, D4 and D5 are the outputs. So um, you what you're basically doing is describing a module, calling it top, and then you're basically just telling in Verilog the inputs and the outputs, and then within this module you do some magic, uh, which we'll see in the later videos. But you basically do some magic and then hit make and convert it into the bin file. So now let's do it again. Let's just hit make and just wait for our .bin file to appear. So it will take a while. Come on. And yeah, there it is. So again, if I do ls, we can see that rot.bin is here. Now let's go ahead and flash this. To flash, what we'll have to do is iceprog, use the iceprog utility, and then just pass to it the rot.bin file. So what it's going to do is it's going to take the rot.bin and pass it over to the FPGA. It's basically going to program your FPGA. So right now, if we look at the FPGA, well, what we see is we see 4 red lights and 1 green light slightly just turned on, and nothing really is happening there. So now once I hit iceprog rot.bin, what should happen is it would push all the code onto the FPGA, and now we can see that the red LEDs are blinking in a rotating fashion. So yeah, that's about it. That's what that basically completes our setting up of the environment for the FPGA development. And in the future videos, we would maybe develop simple examples and then take a look into the internals of the FPGA. That would be our main intention. So yeah, until then, goodbye. Thanks for your time.